Okay, this is A.SSE.3.c Algebra, Seeing Structure and Expressions 3, Subpart C, Video 1. How exciting. Today we're going to be applying exponent properties involving products and quotients. Here are a few terms to know. I'd like you to write these down in your journals and define them. Okay, this video is going to consist of many properties involving exponents, and it's really just going to be me working out a bunch of problems. I feel like this part of algebra is a lot of repetition, a lot of practice, and we're going to be using these properties when it comes to graphing these exponential functions later on in the chapter and later on in this year. So let's roll through all of these properties, and when you get to class, I'll have a number of examples that we can work out that have all these properties in it. So if this video goes a little longer than usual, I apologize. There's a lot to this. All right, the first one, product of powers property. So powers are your exponents, and product means we are multiplying. And we have some very specific rules when it comes to these bases. And the base is this red letter A. So if the bases are the same and we are multiplying, there's your product, we are going to take these exponents and add them up. And it's very important to note that the only way you can do this property by adding these exponents is if this base A, they have to be identical to each other. So then you're going to take the base, keep it the same, and then add up your exponents. So let's look at a couple examples. All right, so we have base 7 raised to the third power. So 7 cubed multiplied by 7 to the fifth. We have our common bases. We're going to keep that base 7, and then we're going to add up those exponents. And you're going to get 7 raised to the 8th power. And if you want to, I'm not going to go through this for every problem, but if you were to write this out, 7 to the third power, and then multiply that by this 7 to the fifth power, how many 7s do we have here when it comes to this product? Well, 1, 2, 3, 4, 5, 6, 7, 8. That's why we are able to take this quick property rule, add up the exponents when the bases are common. We don't want to have to write out all of these 7s to come up with that answer. All right, the next one, 9 times 9 to the 8th times 9 squared. This is an invisible 9 to the first power. A lot of students forget that that is to the first power. So then our answer would be 9 to the 1 plus 8 plus 2. So we have 9 to the 11th power. All right. Now, I'm going to go through a couple examples today with these negatives in the parentheses. This is another common error that students are making when we have the negatives on the interior of the parentheses or negatives on the exterior. So this one, we have in parentheses the quantity of -5 times the quantity of -5 to the 6th power. Again, recall this is -5 to the first. So we're going to keep it in the parentheses. That's very important. Add your exponents. And we have the quantity of -5 to the 7th power. All right, the last one, I threw some variables in there. It's the same idea. If we have the same base x and we're multiplying, this is the product, we have x to the 7th power. Now I didn't plan those both being the 7th power, it just worked out that way. All right, next property. Now we have this property called the power of a power. So basically we have a base exponent, m raised to the nth power. So we have a power raised to another power. And the quick rule to this is that we're going to keep our base and we're going to multiply these two exponents together. So we have 4 squared to the 7th power. So if I'm following my quick rule, that's 4 to the 2 multiplied by 7, which is 4 to the 14th. Now where did that come from? Well, if I were to have 4 to the 2nd power 7 separate times, it would look like this. 4 squared, 2, 3, 4, 5, 6, 7 separate times. And if we were to multiply all of these out, the product, like our last property, I have the common base of 4. I'll just write it up here. The common base of 4, and then we are to add our exponents. Well, 2, 4, 6, 8, 10, 12, 14 if I were to add up using our previous property. All right, so a quick rule as to why we have this power to a power. All right, so now in the second one, we have this example that have brackets and a power to a power. So we have 2 separating grouping symbols. And basically what this is saying is we have the quantity of -2 raised to the 4th power, and all of that raised to the 5th power. All right, so there is your power to a power. It just happens to be a negative. So we'll have -2 to the 4 times 5, in parentheses, 20. All right, last one. Same idea. We have this quantity of m plus 1, it raised to the 5th. That idea is raised to the 4th. So here's another power to a power. We're going to keep our quantity symbol. We don't know what m is yet, so we're going to have to keep it added to 1. And if the book tells us what m is, we can substitute in the m with any number variable, any integer, add it to 1. That answer raised to the 5th, that raised to the 4th. How exciting. Okay, now we have a power of a product property. So all of these properties are dealing with a product right now, multiplication. So now we have inside of our parentheses 2 different terms. So we have an a and a b, and those are raised to the mth power. Well, it's kind of similar to the last one in which we have a power raised to a power, because a has a power of 1 right now, and b, because they didn't give us anything, so it's b to the 1st power, and that is raised to the mth power. That's not a good m. Let me change that. All right, so if we were following our power to a power, we would have a to the 1 times m, b to the 1 times m, and that's why we come up with this a to the m, b to the m. Look at some examples here. So here's our product. We have 2 different bases. We have 24 and we have 13, and those are raised to the 8th. Well, that would be 24 to the first power times 13 to the 1st power, all raised to the 8th. So that would be 24 to the 1 times 8 times multiplied by 13 times 1 times 13 to the 1 times 8 is also 8. And if it's said to simplify this, well, basically what we're going to do is, in this case, probably take out a calculator and figure out what this product is equal to. But right now, it does not want us to simplify this particular example here. Next one, 9xy squared. So that is, again, every term on the inside raised to the 2nd power. So that would be 9 to the 1st, x to the 1st, y to the 1st, all of that squared. So here's our power to a power. Well, 9 to the 1st to the 2nd is 9 to the second, which is 81. 9 times 9 is 81. X to the first to the second is x to the 1 times 2. So x squared, and then we have y to the 1 times 2 is y squared. All right, now here's where I was leading into from a couple screens ago when I said how important this parenthesis is with the negative. Now the negative is inside this grouping symbol, and the grouping symbol is important in that it tells the reader that the exponent will be, I'm not going to call it distributed, but it works with each term on the inside. So we have a negative being squared. Well, what is a negative squared? That would be a negative times a negative, which is a positive. So if I have a negative squared, my answer will be positive. 4 squared is 4 times 4, which is 16. And then z to the first to the second is z squared. So final answer would be 16z squared. Now, if this was a to the third power, it would be a negative times a negative times a negative, in which case that answer right here would change to that negative 16z to the second. Why don't I show you that? So if it was negative 4z to the third, everything would be raised to the third power. So negative, negative, negative would equal a negative answer. 4 times 4 is 16. 16 times 4 is 64 z to the third. I just wanted to show you that because it really shows how this negative gets applied to the exponent. All right, now the negative is on the outside of the parenthesis. So the only things that get squared are the items on the inside of the parentheses. So here I would have an attached negative sign on the outside. 4 to the second power is 16. Z to the second power. So here's the difference between these two answers. Very important that we have noticed the difference from when the negative is applied from the inside or the outside. I'll show you that more in class too. That gets confusing. All right, now we're moving into this quotient of powers property. Now, quotient is your division, and it usually entails this fraction bar. All right, so same idea. The bases must be the same in order for us to now subtract the exponents. So when it was a product, we were multiplying and adding our exponents. Now that it's a quotient, the opposite of multiplying is dividing. So the opposite of adding is now subtracting. Common basis. So now we have the quantity of negative 3 to the 9th divided by negative 3 cubed. So our answer would be keep the base the same and subtract the exponents. 6th power. And the last one, we have a fraction. Oh, so I kind of combined the two of them here together. We have a quotient, and then we have a product with another term. All right, so just think of your basic math skills when it came to multiplying fractions. We need to take this term, turn it into a fraction that doesn't change its value, so we could always put it over 1. So let's put that over 1. Multiply straight across. 1 times x to the 6th. X to the 4th multiplied by 1. And now we have, look at, same bases. Bases must be the same to perform this quick property rule. That would be x to the 6 minus 4, which is x squared. All right, power of a quotient property. So we're sticking with this quotient. Now we have inside the parentheses two different bases, call them A and B, and it looks like we are taking the power to a power rule again, even though it's a quotient. So we have A to the first power to the m over B to the first power to the m gets us A to the m over B to the m. Important note, B cannot be equal to 0. You never want, let's just call it 4. I don't know, I made it up. You can't have 0 in the denominator. This B right here can never be, well, this total answer here, whatever your B to the m is, if it comes out to be a 0 answer, that would not work for us. This is called a undefined fraction. All right, last example. So we have a quotient, we have an A and a B. Notice these are different coefficients. And then we have also different variables. And these are a quotient with a power to a power. Yikes. 4 is to the first. We have x squared. 5 is to the first power. We have y also to the first power. So let's do the numerator first. So 4 to the first to the third, we said power to a power, we multiply. So that would be 4 to the third. X to the 2 times 3 is 6. And then we have 5 to the first to the third. So 1 times, so that would be 5 to the third. Y to the 1 times 3 is 3. Let's simplify. 4 to the third power is 64. X to the sixth. Then 5 to the third is 125. Y to the third. And look to reduce your fraction if possible. If it's possible, we're going to reduce this. And then we have these variables, x and y. Now, since these are not the same bases, we cannot subtract these exponents. They must be the same variable, and they're not. And I don't believe we can reduce these any further. So I'm just going to recopy it for you. It's the same answer as above. Final. All right, in your journals, please define the given terms on page 2 of the flip chart. Write a few sentences on what you learned from this video. If there's any questions, put a little mark in your notes so that you can bring those questions to class and we can all answer them together. And I apologize for the length of the video. In addition to that, I want you to know that repetition, I'll say like I said before, repetition, practice of these problems, they're going to look quite intimidating and scary, but I think once we work some of these out together, it's not going to be horrible for you. I will see you in class.